Hi, my name is Grzegorz Osipowicz.
And I'm Laura.
We represent the Institute of Archaeology of the Nicolaus Copernicus University in Toruń, and we would like to tell you a few words about our recent experiments connected to our studies on the prehistoric osseous collections.
We hope you will like it.
Traceological studies of osseous artifacts have a long tradition and can be divided into two main streams: research related to technological issues and typical functional analysis. An important part of both types of research is experimental archaeology. In our presentation, we will demonstrate the most interesting recent examples of our works connected with a different kind of osseous artifacts. Most of them is connected to the traceological studies we realize on a collection of osseous artifacts from the hunter-gatherer fisher sites in Šventoj at the Lithuanian Baltic Sea coast. During the excavation carried out at the complex of subneolithic site in Šventoj, 27 extremely interesting bone products have been discovered. Due to the characteristic of the usual and technological traces, which are readable on the surfaces, they were defined as scrapers. Next to the experiments done before in our institute, we conducted several new experiments to find an answer how this tool could have been used that were planned in regard to the economic profile of site in Šventoj. In the course of these experiments, replicas of scrapers were used for scaling fish and fleshing the hides using their mixture of charcoal and ochre. In the course of the fish scaling experiments, 19 relatively large perches were treated. The experiment was conducted as fish remains are a significant part of the collection of bones from site in Šventoj. Fish processing did not bring any greater problems, and the work was finished in 34 minutes. The decision to experiment with hide scraping with the admixture of charcoals and ochre was based on the characteristic of the usual traces observed on the original scrapers from Šventoj, as well as ethnographic data on the substances used during the hide processing. In the first stage of the experiment, fresh seal hide was worked. Initially, it was cleaned using flint knives to remove most of the fat. Then, we have started work with the use of replicas of Šventoj scrapers. The work was halted as the scraping of a wet and highly fat hide proved ineffective. The second stage of the experiment was conducted after drying the hide that was stretched on a frame for about 1.5 of a week. 2 scrapers made of seal tibia were prepared for this experiment. The work comprised rubbing ochre into the hide and scraping off agglomerated fat and the flesh until completely removed. In the case of dry hide prepared as above, the tools proved highly effective. The experimental hide processing using that mixture of charcoals was performed using the bovine hide. The next step was the traceological analysis of tools used during the experiments, the result of which were compared with the data obtained during the usual analysis carried out for the Šventoj scrapers. As a result, the most similar functional damage those visible on the artifacts was observed on tools used to scrape the seal's hide with addition of ochre. This observation was confirmed by chemical studies that led to the identification of increased iron content both on Šventoj and experimental tools. The results of these studies were recently published. At the sites in Šventoj, also a rich collection of animal teeth pendants have been discovered. The main goal of the traceological and experimental studies associated with these artifacts was to answer the question of how animal teeth were modified to create the pendants, that is, what techniques and tools have been applied for this purpose. Another aspect was the usual analysis aimed at determining whether the tooth pendants from Šventoj were used, and if so, what was their real function, how they were mounted to the clothes if they were. As it appeared, after microscopic analysis, the technological traces observed on the artifacts include generally only the traces associated with making the perforations. From this point of view, the artifacts can be divided into groups of specimens with holes drilled, scraped, and made with the use of both techniques. For the sake of the experimental work, different types of incisors were obtained from the wild boar species, 64 teeth in total. Then, holes were made in the teeth using several options of the bilateral drilling technique by analogy to those observed at the artifacts from Šventoj. The next step was focused on testing the variability of usual traces formed on the pendants as a result of using in various ways and mounting with the different types of twine. Experimentally prepared pendants were used to make elements of clothing as necklace, bracelet, and bands. Each category was made with the use of two types of string, the hemp twine and the thong. They were worn for a month on a daily basis by members of the archaeological expedition, both at work at the excavation and during the regular activities at the base. The result of user studies of the experimental pendants showed no characteristic of wear traces which definitely distinguish the type of twine used in the experimental program. Nonetheless, the experiments conducted, the microscopic analyses have confirmed the direct relationship between the location of used traces inside and near the hole and the way the pendants was used. The results of these studies were recently published. The starting point for the next works we present were the results of the traceological studies of a collection of seal craniums also discovered in Świętoj. On their surfaces, we have noticed the technological traces and well-developed use damages, the characteristics of which most likely indicate the use during ritual practices, possibly in a similar way to that suggested for antler frontlets known from several Mesolithic sites. The results of these studies were also recently published in the Journal of Archaeological Science Reports. The starting point for the next performed experiments was a collection of the unique artifacts made of animal scapula discovered at the Bronze Age site in Pruszczewo in Poland. The experiments aimed to answer the question what activities this object could have been used to. The type of work conducted and the treated raw materials were selected based on the general character of the useware identified on the working edges of tools and the suggestions from the publications. One of the first activities to be checked was processing of flax. First, bundles of cut, dried and ground flax seeds were soaked in water for 2 weeks. After this time, the flax was dried, making it suitable for further processing. For this purpose, 2 tools were used to break the stalk while separating the fibers. The tools worked effectively and the flax fiber was obtained fast in an easy way. Another experiment carried out was related to use the knives as weaving tools. 100% sheep wool yarn was used here to warp and weft. For the work performed, the tool consisted of pushing the weft while weaving a narrow selvage. The second experiment carried out connected with wool processing was felting. Wool from heater sheep was used for this purpose. It was felted with the hot water on a mold to obtain the shape of a container, a bowl. The next tested activity was wood painting with the mineral dyes, ochre and chalk. Both dyes were mixed with the pure animal fat. A wall made of pine boards was painted with the prepared dye. The Pruszczewo knives served here as a kind of trowels. For the painting with ochre, 2 tools were used. The covering of the surface with both ochre and chalk was effective. The usefulness of knives as tool for spreading and smoothing the daub on the walls was also experimentally tested. To do this, a mixture of clay and sand was prepared. During the experiment, 2 replicas of knives were used to spread the daub on the wattle wall. Additionally, 1 knife was used as a spatula for merging coils during the production of the pottery, using the rolls technique and smoothing its surface. For this purpose, a clay with that mixture of crushed stone was prepared, similar to the one used at the site in Pruszczewo. After that, a skilled person started making a large storage vessel. The Pruszczewo knives were also tested in animal hide processing, the activities as fleshing and hair removal. In both cases, fresh deerskin was treated. First, the remains of meat and flesh were removed with one of the knives. The performed movement was similar to scraping. After cleansing, the hide was placed in water with ash for 1 week. Then it was deharrowed with the second tool. At the moment, the experimental works has been completed, and now it is time for making proper traceological analysis of all tools. We hope that thanks to the conducted experiments, we will be closer to solve the riddle of the function of the discussed Pruszczewo knives.
Another ongoing experiment is connected with a collection of the bone eye skates discovered at the early Middle Age site in Ostrów Lednicki in Poland. Skates discovered on the mentioned site varied in types of used long bones for their production, and the degree of use were traces visible both on their upper surfaces and on the sliding surfaces. Our experiments aim to answer the question of how different types of skates were used, and were they used on ice or maybe on snow. One of the first activities that we checked was ice skating and skiing on the snow. For this purpose, we prepared skates made from radial and metacarpal bones of red deer. During experiments, skates were attached to feet with leather straps. We used two wooden poles with metal ends for pushing forward. Ice skating was very effective, in opposite to sliding on the snow. We also checked the usefulness of the skates as an element of the sledge. We made small wooden sledges and fastened bone runners with leather straps to them. Sledges were tested when sledging from small snowy hills. Radial bones best fulfill their role in this case. At the moment, the experimental work has been completed, and now it's time for making proper traceological analysis of all experimental skates and compare them with skates from Ostrów Lednicki. Our experiments are very often associated with better understanding of different technological aspects of bone processing. In prehistory, grinding was performed mostly with different kinds of stone slabs, which served as a kind of abrasive tool. However, the differences between many identified traces observed on bone objects, described as a result of grinding, still raise many questions about used materials and techniques. This is why we have begun an experimental program which the main objective was to classify, analyze, interpret and correlate the macro and microscopic traces formed on the experimentally worked bone materials, caused by different kinds of grinding techniques. During experiment, fragments of red deer long bones, metapodials, were used, which were divided into blanks, on average size of 2 cm wide and 5 cm long. Grinding was applied on the external surface of the bone. 5 different types of stone were used, which varied with grind size and toughness: yellow quartz sandstone, red quartzite sandstone, quartzite, and 2 kinds of gneiss. In each case, the bone was ground with and without water. Additionally, was also tested admixture in a form of dry and wet sand. Bones used during our works were dry, but also softened in water. Conducted experiments resulted in many observations on both the effectiveness of type of stone used and the working technique. An important element was the hardness, porosity, and granularity of the stone slab, which reflected into the efficiency of work and the final shape of the processed surface. The next step of our study will be focused on detailed description and interpretation of obtained data, which will be also compared with selected osseous archaeological materials. We hope to present the detailed results of these experiments soon in a proper publication. As we can see, experimental archaeology is a very important element of many traceological studies performed in our institute, and is a crucial method for better understanding of the past. A properly performed experiment results in acquisition of data, which can be compared to observations made on an archaeological source. This leads to conclusions answering, in this or other way, a question posed before the process, and might also constitute a basis for formulating further hypotheses verifiable in an experimental way.
We hope you enjoyed our presentation. We are waiting for your questions.
If you have